Hello aspirants and a very warm welcome to you all. My name is Madhusudan Reddy and in today's session we shall be covering up our next theme, that is theme number 6, climatology part 2. In the last class we have learned about what is insolation, what are the different types of rays that comes onto the surface of the earth, as well as how does the heat is taken by the earth and how the heat is released by the earth. Across the regions of the earth we have looked into the heat, atmosphere, pressure belts, as well as we have also learned how the winds move on the earth. Now in today's lecture we'll go little more ahead and we'll try to understand the water in the atmosphere as well as world climate and climate change. In this particular theme you're supposed to study these two chapters, part 2 of climatology, that is chapter number 11 from class 11 and go to chapter number 12 of class 11. Right, these are the chapters. Now what are the names of the chapters? Let me again read for you. It is water in the atmosphere is class 11 chapter number 11 and class 11 chapter number 12. It is world climate and climate change. Now let me also show you the chapters here itself. Look, this is one chapter, that is, just a minute, water in the atmosphere. Right. In this chapter, what are you supposed to study? You need to understand how the water is present, what is evaporation, as well as some basics which are there with different definitions. What is saturated air, what is the humidity, what are the different types of humidity, what is dew, frost, and what are the different types of clouds, and a small concept called temperature inversion. In the last class also I have tried to introduce the concept of temperature inversion and what are the different types of precipitation. This is one chapter. And the next chapter that you shall be looking into is the world climate and climate change. In this, you need to know what are the different types of climates that are present across the globe. And one of the major classification which was given by the Koeppen, will also look into it, right? It is asking about world climate and climate change. In that, Koeppen's classification scheme we will be looking into a detailed manner. Now, first let's go into this particular chapter, that is, what is atmosphere? Water in the atmosphere. See, the water in the atmosphere is present in various forms. It can be present in the form of dew. It can be present in the form of moisture. It can be present in the form of clouds. It can also be present in the form of rain. Air that is evaporating, it can be converting itself into multiple ways. Be it your dew, frost, there is also a mist, right? All of this are considered to be the precipitation, right? This is called as precipitation. And this precipitation can be possible only when the air is saturated, right? Now for the first time, you are introduced to some definitions, that is, what is the term relative humidity, which is written in your NCERT, and many students have problem while understanding these topics. So I'll make it very, very simple for you. What is relative humidity, what is absolute humidity, as well as what is dew point and what is the latent heat of vaporization, right? These are few aspects that you need to learn. Now firstly, here I want to introduce you to few terms, that is adiabatic process. Before we learn anything, you have to know that the air which is there, packet of air, imagine this is the packet of air which is present at the ground. Okay? And the temperature here is 35 degrees Celsius, let's imagine, at the surface, right? And as the air starts to rise, there are few things that will be happening. One, the air expands. As the air expands, there will be cooling also that will be taking place. That means any air that is rising, it will undergo. Suppose if this is the air which is having 35 degrees Celsius of temperature, right? If you increase 1 kilometer, the temperature will decrease by little more. Likewise, the temperature might decrease by little more. As you go higher, the air expands and here it cools. Once the cooling starts, the same air will come down. While it is coming down, it will heat. this particular entity, you can also call it as an adiabatic process. First, what is adiabatic process? The definition here, it clearly says that adiabatic process refers to heating or cooling that occurs slowly as a result of pressure change. See here, it is a result of pressure change with no heat flowing into or away from the volume of air, right? Adiabatic process is where this process, it refers to a heating or cooling. Either you heat a packet of air or you cool a packet of air that occurs solely as a result of pressure change. That means you keep the temperature constant and you keep on changing the pressure. Now let me tell you, in the day 1 itself, in the day 1 or 2, we have learned that as you rise into the higher regions of the atmosphere, it is always the upper regions of the atmosphere will have less pressure. Now let's imagine this entire column of air is having similar kind of temperature, right? Let's imagine the entire column is having similar kind of temperature. Irrespective of that, if the air is experiencing a change in the pressure and keeping the temperature more or less the same, and also heat flowing with no heat flowing into or away from the volume of air, then this is called as adiabatic process. In simple terms, I have to tell you that anything that rises, what happens? It will undergo expansion and cooling. Anything that rises, it undergoes expansion and cooling. And remember one thing, the heat which is present within this particular packet of air, the heat is not exchanged. Heat is not exchanged from packet of air to outside. From packet of air to outside, heat is not exchanged. The heat which it is having is not exchanged. So this is called as adiabatic process. Now through this adiabatic process, anything that rises has to, one thing, anything that rises, it has to expand, and whatever that expands, it cools down. And once the cooling takes place, it will start to sink. Now anything that sinks will start to contract, and contraction and heating will take place. This is called as adiabatic process. In this, we will also learn about the further aspects, right? See here, now come to understand some of the keywords. Keywords are, that is your humidity, absolute humidity 1, and relative humidity. First, look here, humidity means, imagine this is a packet of air. In this packet of air, you will be having air molecules, and these air molecules are also having moisture. Then let's say that there is some amount of moisture which is there. Let's say 20% of moisture is there in this entire atmosphere. Now what is humidity? Humidity is 20%. This is what we say. Generally, what is humidity? The amount of moisture present in the atmosphere. If not, I can put it in different ways. Look, I can say, if suppose this is a packet of air, now how much moisture is present in this packet of air? If I ask you how much moisture is present in the packet of air, you will tell me, sir 10% हो सकता है, या ये 10 किलो का पैकेट है तो इसमें 1 किलो का पानी हो सकता है. Or you can say that, sir, in this I can fit 10 liters of water and only 1 liter of water is there. Can I say that 1/10 of this particular packet of air is filled with moisture? I can say in different ways, I can tell you in different ways that the air that is present here, this air can be measured in terms of weight. It can also be measured in terms of percentage, or the moisture that is there, it can be measured in terms of weight. The moisture that is there, it can be measured in terms of percentage. If suppose, if you are measuring how much amount of water or moisture is there in the packet of air, if you are measuring how much amount of moisture is there in this packet of air, let's imagine this is your packet. if you are measuring, that is called as humidity. Now this humidity can be measured in percentage terms. It can also be measured in weight. Okay? It can also be measured in weight. If you are measuring this humidity in terms of percentage, that is called as relative humidity. If you are measuring them in terms of weight, this is called as the specific humidity. Or I can also say it can be measured as relative humidity. Sorry, it is absolute humidity. Right? Do you understand that when I am measuring how much amount of moisture is there, if you start to measure the amount of moisture present in a packet of air, that is called as humidity. Now that humidity can be measured as in terms of percentage. When you are measuring in percentage, this is called as relative humidity. In terms of weight, then that is called as absolute humidity. Your NCERT will try to tell you one thing. See here, many students will have problems in understanding this absolute humidity. It is weight of water vapor present in the unit of volume of air is expressed in terms of grams per cubic meter. That means it is expressed in grams per cubic meter. It is grams per cubic meter. This is what is how it is expressed. Now you take in terms of, this is your packet of air. Let's say that this is your packet of air. In this packet of air is having, maybe let's call this as a cube. It might be having a weight of, let's say a weight of 200 grams. In this 200 grams of moisture is there. Right? I'll say in 1 meter cube, this is 1 meter cube. In 1 meter cube, how many grams of moisture is there? If I say in this 200 grams of moisture is there, I'll say what is the absolute humidity? Absolute humidity is 200 grams per meter cube. That means I'll take a 1 meter box, a box of 1 meter length, and in this I'll measure in the atmosphere how much amount of moisture is there. That is called as your absolute humidity. Now then, what is relative humidity? Relative humidity is the same amount of moisture you wanted to measure in percentage terms. That means in terms of percentage. For example, let's say this particular box can be holding 100% of moisture. Let's say I'll divide the entire box into 100 units like this, and like this there are 100 units that have been divided. Now these 100 units like this. Now see here, when you are measuring absolute relative humidity, you will be taking this has 100%. Now how much percentage of moisture is there? Let's say this is filled with 10% of the moisture or 20% of the moisture. Right? This is what is relative humidity. Relative is always there is a potential. The potential to hold the moisture is 100%. And in that, how much moisture is present? If it is 20% of the air is filled with 20% of this packet of air is filled with moisture, then we say that the volume of the percentage of relative humidity is 20%. Right? So let me show you the definitions here. Definitions is, in terms of relative humidity, the percentage of moisture present in the atmosphere as compared to its full capacity at a given temperature is known as relative humidity. The percentage, look here, it is the percentage of moisture present in the atmosphere, percentage of moisture present in the atmosphere as compared to its full capacity. What is its full capacity? Full capacity is always 100, right? Now what is the percentage present? Maybe 10, 20, like that. At a given temperature they have said. Now see here, you need to understand one more thing. Suppose in relative humidity, the relationship between temperature and relative humidity, I'll write it as relative humidity, is not directly proportional, it is inversely proportional. It is inversely proportional. That means if you are increasing temperature, relative humidity will decrease. If you are decreasing temperature, relative humidity will increase. Remember this. relative humidity will increase if you are decreasing the temperature. Relative humidity will decrease. It will be reverse. If you are increasing the temperature, relative humidity will decrease. If you are decreasing the temperature, relative humidity will increase. So let me show it to you here. Firstly, the definitions of the relative humidity. Look here. And absolute humidity. We have learned that the actual amount of water vapor present in the atmosphere is known as absolute humidity. It is the weight of water vapor present per unit of volume of air as is expressed in grams per cubic meter. That means if you are measuring, if you are taking a 1 cube and this cube, if you are measuring in grams per cubic meter, this is your absolute humidity. Likewise, I also want you to look into this particular entity, that is relative humidity. The percentage of moisture present in the atmosphere as compared to its full capacity at a given temperature is known as relative humidity, right? It is greater over the oceans. It is greater over the oceans and less over the continents. With the change of air temperature, the capacity to retain moisture will always reduce. Remember this, with the change of air temperature, the capacity to retain moisture increases or decreases and the relative humidity is also affected. Now let me try to explain this particular point. What is the relationship between the relative humidity and temperature? Now let's imagine that you have this is at 0 kilometers height. This is at 2 kilometers height, this is at 5 kilometers height, and this is at 10 kilometers height, right? Let's imagine that like this. Imagine this is a packet of air. Okay? In this packet of air, let's say it can hold the actual amount of moisture it can hold is 100%, right? What is the temperature at this particular? Here I'll also draw like this. See here, this is the height, right? This is the cloud or the packet of air, and this particular entity is how much amount of moisture, that is relative humidity, is there, right? And this is temperature. Let's imagine that at 0 kilometers the temperature is somewhere around 40 degrees Celsius. At 40 degrees Celsius, the air or the cloud, let me take this as a cloud. Okay, I'll draw it as a cloud. This is a cloud, right? What is the potential of this particular cloud to hold moisture? It is 100%. Remember, when you are decreasing the temperature, the potential to hold the moisture will reduce. Look, see here, let me write it like this. When temperature is reduced, the potential to hold moisture also decreases, right? I'll add one more column here to make it little more easier for you. This is the actual, I'll say that this is the actual moisture. Okay? If not, in this, how much moisture is present? This is the actual moisture. Let's say always the relative humidity, the potential to hold this particular cloud is 100% and the relative humidity is 100%. Now if I'm reducing, I'm going to 2 kilometers height and the temperature would be reducing by 12 or 13 degrees Celsius. The temperature here is 27 degrees Celsius, right? The temperature here, it could be 27 degrees Celsius. At this 27 degrees Celsius, the potential to hold the moisture, okay, the potential to hold the moisture itself will be reduced. How much is the potential here? Here it is 100% is the potential of the air to hold the moisture, but now as I am reducing the temperature to 27 degrees Celsius, the potential to hold moisture is hardly 75. Okay? Imagine 75 units itself it can hold. Earlier 100 units is the moisture that it can hold, but now 75 only. What is the potential? The potential is reduced to 75. Now what is the relative humidity? 75 is how much of 100? It is 2/3. 75 is 2/3. It is 2/3. 75 is 2/3. Right? 75 is 2/3 of 100. Now the relative humidity will be, instead of 100%, it is going to be reduced. Likewise, in other words, I can say that as you are increasing the height, only 50 units is the moisture that it can hold. Right? As you are decreasing the temperature, only 50 units is the moisture that it can hold. Likewise, if you are reducing, only in this particular air, only 25 units of moisture it can hold. So as you are decreasing the temperature, the moisture holding capacity of the cloud will be reduced. And in other words, I can tell you that, imagine at this temperature, at the lower temperature, 0 kilometers, the moisture holding capacity is, this cloud can hold 1 liter of water. Now if I am taking to 2 kilometers height, this cloud can hold, the cloud water packet size get shrinked, and the cloud can hold only this 1 liter of water. It cannot hold overall 1 liter of water, it can hold little less. Likewise, as you go to the highest points, there will be a point of time where the entire cloud, they will be filled with water. If this cloud is filled with 100% of moisture, and this will be the cloud which it shall be raining. And the temperature at which it starts to rain, or the temperature at which it starts to fill the cloud is entirely filled, that temperature is called as dew point. Dew point is the temperature. Whereas the condition when the entire cloud is full, with moisture, this condition is called as saturated cloud or saturated vapor. Right? This is called as saturated vapor. Saturated air or saturated condition. Okay? Clear? See, I know many students, you will have doubts. I want you to read that particular chapter. This is one particular topic you will have to spend little time to analyze, because this is not physics, this is physical geography. In this, let me sum it up here, the relative humidity and the relationship between the temperature. Let's imagine there is a cloud. Okay? And if the temperature is high, this cloud can hold more moisture. Right? If the temperature is high, this cloud can hold more moisture. Let's say this cloud can hold here 1000 ml of water, but I have decreased the temperature. Right? Imagine the cloud, 1000 ml of moisture, this is the total moisture it can hold, and currently it is filled with, let's say it is filled with 700 ml itself. Right? It is filled with 700 ml. How much more it can hold moisture? It can hold somewhere around 300 ml more moisture it can hold. But if the same cloud, I am going to reduce the temperature, what happens to the potential of the cloud? The potential of the cloud to retain moisture will be less, to hold moisture will be less. That means at decreased temperature, imagine this is 40 degrees Celsius, imagine this is 27 degrees Celsius. At 27 degrees Celsius, this cloud can only hold 800 ml of water. That means, look at this, in the previous condition, I told you that this cloud can hold 1000 ml, but this cloud currently has 700 ml of water, right? Only has 700 ml of water, but I am taking this cloud to little higher height. When I am increasing the height and decreasing the temperature to 27, or maybe reducing the temperature, at that the cloud can only hold less water. In this, you see what is the percentage of moisture this cloud is filled with? This is more, and only 20% of see here, this is the area where the moisture can be retained, or where the moisture can be holded more. The red color area is the area where the moisture can be added. Only 100, let's say that in this cloud is also having 700 ml of moisture, and it can hold only 100 more units. But in the previous case, it is having 700 ml and it can hold 300 more units of moisture. I am going to reduce the temperature little more. I am going to increase the height and I'll reduce the temperature to 21.5 degrees Celsius. At this height, the same cloud will not be in a position to hold 800 ml. It can only hold 600 ml. Or let's say it can hold only 700 ml of water. In such a case, already we have this 700, the entire cloud will be now filled with 700 ml of water. If the cloud is completely filled with the moisture, okay, what is the potential of the cloud? The potential of the cloud is, this is potential of the cloud. The potential of the cloud is getting reduced. When I say, when 700 ml of water is the potential of the cloud and 700 ml of moisture is retained by the cloud, now this is the time when you are going to see the rainfall, right? This condition is called as, this entire condition is called as saturated air, right? And the temperature at which the saturation took place, this is called as dew point, right? This is called as dew point. I think with this understanding, you got to understand what is the concept of relative humidity. Relative humidity, as you are increasing the temperature, look here, it is 21, 27 and 40. Here the relative humidity is less. Relatively it is less. It is having 100% of potential to hold moisture, but it is holding only 70%. Now here, as you are decreasing the temperature, the relative humidity is almost 100%. It is, the relative humidity is 100% here, because the potential to hold the moisture and the total amount of moisture is same. That is what is your 100%. But here the relative humidity could be 70%, right? 70%. Why? Because only 700 ml of water is there out of 1000 ml which it can hold. Can I say that relative humidity is the percentage which is calculated to its fullest potential carrying capacity? Yes. Now this is what is the concepts of relative humidity. It will, with increase in temperature, the relative humidity decreases. With decrease in temperature, that is, I mean decreasing the temperature, the relative humidity increases. And at 100% of relative humidity, the temperature at which this 100% attained is called as dew point, right? So this is what you need to know about this particular entity, right? With this, now let's quickly move to the next topic, that is your clouds. Clouds is one of the most important topic that you have to know. In this, clouds are considered to be the one of the important topics. Here, how many different types of clouds are there, how these clouds are formed, let's try to understand in a detailed manner. And the other topics that are there in the advanced sessions, and so I'll be taking in a very detailed manner, so please be there with us in the advanced sessions as well. Okay, come to the topic of clouds. See here, firstly, what are the different types of clouds that are there that you need to know, and also you also need to know how the clouds are formed. Okay, there are various ways through which the clouds are formed. Here I'll be explaining you in a detailed manner the formations of the clouds. Before that, I wanted to show you these things. I think you might have seen this type of cloud. See, relative humidity is a very advanced concept, but at this level you only need to know the definitions. In the further time period or in the advanced classes, I'll definitely explain these aspects in a detailed manner, right? It takes a lot of time to explain relative humidity, but you need to know the definition and the relationship between the topic. Okay, don't worry. And if you have, while you're reading, any doubts, and if you had any doubt in the relative humidity concept, you can also drop a message to this particular number, right? I'll be very happy to address your doubts as well. My name is Madhusudan Reddy, right? Okay, so see here, you might have seen this type of cloud. This cloud is called as cirrus cloud. You might have also seen this cloud. This is called as cumulus cloud. Likewise, there are layers in this cloud, and this cloud is called as stratus cloud. You might have seen this cloud too. This is called as nimbus cloud, black color. And this is called as a cumulonimbus cloud. Look how big it is, how tall it is. The height of this cloud can go up to 10 kilometers height. This could be the cloud, like a tree, tall and tall. And this is the cloud that will give you thunderstorms and lightnings. So let's try to understand how these clouds are formed. Basically, you will come across that these clouds are nothing but the collection of moisture. Now, how this collection of moisture is there, let's try to understand. See here, cloud is a collection of dust plus water droplets, okay, which together comes to cloud droplets, and a collection of cloud droplets will become a cloud. In simple terms, let me tell you, imagine there is a dust particle which is there. And this dust particle, if it is charged, or any sunlight, or if you have a good amount of charge in this dust particle is called as hygroscopic nuclei. Okay? Around this dust particle, if there is any water vapor that is there, it will go and bind with the water vapor. Right? This binding of the water vapor is now called as cloud droplet. This will be one cloud droplet. Like this, you have collection of cloud droplets, and this collection of cloud droplets will be called as a cloud, right? So this is one cloud. In a cloud, you will have cloud droplets and one hygroscopic nuclei, right? This is one cloud droplet. Like that, collection of cloud droplets is called as cloud. Now there are four different types of clouds. One is called as cirrus cloud. Four different types of clouds. Even in your NCERT they mention about these four. Let me show it to you. Clouds are of four different types. One, it is your cumulus, stratus, nimbus, and here cirrus, right? Cirrus is a high cloud. This is called as a high cloud. Cumulus is also a middle cloud, or else it can also be found in the lower regions, and it can also be found in the higher regions. It is somewhere with respect to height, they can be present at a height of 7,000 meters. They can be present 4,000 to 7,000 meters. Cumulus clouds. That means this cloud can be present at 4,000 to 7,000 meters. Let me show it to you. This cloud, 4,000 to 7,000 meters. This is present at above 7,000 meters. And stratus, it can be present at little lower height. And nimbus, this is the cloud that has rain. It looks black in color and it can rain properly. Now look here, clouds can be divided into upper clouds and lower clouds. Clouds can be divided into three types. One, these are high clouds, and these are medium clouds, and this is low clouds. There are three different types of clouds: high, medium, and low. High clouds are cirrus in nature. In this, there can be a combinations. For example, this is your cirrus, which looks like a feather, right? If this feathery clouds, which is cirrus clouds, which are present above 7,000 meters and has a shape like cumulus, cumulus has a base and it looks like a wool, then this cloud is called as cumulo nimbus, or else, sorry, this cloud is called as cirrocumulus. Cirrocumulus. If the same cloud is having layers, then the high clouds which are having layers, they will be called as cirrostratus. That means what are the high clouds which are present above 7,000 meters? It could be three clouds which are one, cirrocumulus, cirrostratus and cirrus. Right? Come to middle clouds which are present up to 7,000 meters. Right? And above 2,500 or 3,000 meters. That is called as cirrus clouds. Now these cirrus clouds are also called as altus clouds. ALTUS, altus, or else alto clouds. ठीक है? Alto clouds. Now these alto clouds, which are also called as alto cumulus. Alto cumulus means there is a base which is present in the middle and it has cumulus kind of characteristics, right? Alto cumulus. Cumulus is nothing but the shape itself will be called as cumulus. Look at this. This cloud has a beauty that there is a base, and in your childhood also you might have drawn these clouds, right? This is called as cumulus. This is a woolly substance. Wool like situation will be there, right? And this is a base. You'll have a base and cumulus, right? Right? Okay. See here. Now come back to the classification here. The same clouds will now, if suppose the middle clouds are layered like this, they are called as altostratus, right? And nimbus, it can be present at the lower end and it can go up to somewhere around 3 to 5 kilometers height. That is called as nimbus, right? Now come to the lower clouds. Lower clouds, cumulus can also be present in the lower clouds. Stratocumulus, like layers and cumulus, it can be present in the lower heights, and nimbus can also be present in the lower heights. But here, which clouds can rain and which clouds cannot rain? It is this cumulonimbus cloud, which is the high cloud, thick cloud. This will thunder. Thunder, storm will come. In this, lightning will be there, right? Whereas nimbus is the cloud which is going to rain. Cumulus is an indication the weather is clear, right? Cumulus is an indication that the weather is clear. Cumulonimbus cloud, it is found usually in the equatorial regions. In the equatorial regions, the cloud is very, very thick. Every day in the evening, you will find these kind of clouds, and these kind of clouds are the ones which will give you lightning and thunderstorm. When you come to cumulus, clear weather, weather is clear. When you come to nimbus, nimbus can rain. Rest of the clouds are combinations. And see here, these clouds are unique. These are called as high clouds. These three. These high clouds, if there is a sun rays, the sun rays can easily pass through these clouds. But if the sun rays is falling onto this nimbus, nimbus will reflect back the sun's rays, right? Or else if it is coming and falling onto the cumulus, cumulus will also reflect back. That means the transparency of the clouds which are present at the higher height is less. Transparency is less. That means, sorry, the transparency is more, not less. The transparency is more. That means easily, if this is a cloud, the sun rays can pass through these clouds, right? But the transparency here, transparency with insolation is less. Okay? Transparency with insolation is less. That means the sun rays cannot pass through, it will reflect back. Right? Thick clouds will be there. They will not let the sun's rays to come down. Right? So in a nutshell, lower clouds help in cooling the earth. higher clouds, they will let the sun rays pass through it. Now this is what is the clouds. There are different types, the same clouds, right? Okay, come to the next topic, that is your temperature inversion. Here you also need to know the types of rainfall and what kind of rainfall do you have. See, there are three different types of rainfalls. One is called as orographic rainfall. The second is called as cyclonic rainfall. The third is also called as the convectional rainfall. That means there are three different types of rainfalls. Orographic, number one. Cyclonic, number three, it is convectional. These are the three different types of rainfalls that you will have. In these three different types of rainfall, orographic means mountain rainfall. Okay? This is called as a mountainous rainfall. In this mountainous rainfall, you see that if this is a mountain and this is a cloud, as the cloud rises its height, the moisture holding capacity of the cloud gets reduced and the total moisture will be filled with the cloud will be completely filled with the available moisture, and finally temperature here reduces. As they rise, they start to rain. But on the other side, as they descend, this will have no rain. Okay? You have rain on one side and you do not have rain on the other side. The rainfall which occurs in the mountains is called as an orographic rainfall, right? And the rainfall which occurs in a cyclone is called as a cyclonic rainfall. And the rainfall which occurs at the equatorial region, every day the heat is high, there will be rising air and these clouds will be formed. These clouds which are formed are primarily because there will be heating that is taking place continuously, and the clouds rise. These thick clouds will convert itself into a cumulonimbus cloud and evenings they rain. So the convectional rainfall is different from the traditional forms of rainfall. You will come across the different types of rainfalls, for which let me show you how this rainfall does take place. It is the convectional rainfall is at the equator, as well as you will come across the rainfall of the orographic rainfall is there in Himalayas. Okay? And if you see the rainfall of orography, it will be like this. On one side you will see, look, if these are your mountains, these mountains, as it helps in rising, and as they rise they'll start to rain on this side, but on the other side they descend, right? The other side they are going to descend, so this descendancy will lead to the non-availability of the rainfall, right? So this is called as orographic rainfall, right? In India, you go to the orographic regions, wherever you find mountains, this is what you will get. The best example for the orographic rainfall is like this. Look here. You have lot of mountains, and these mountains, especially the Western Ghats, these are your mountains. If there is rain which wants to, the southwest monsoons come from this direction, right? This is the direction from which the southwest monsoon comes. So as the southwest monsoon comes onto the India, the problem here is that there are Western Ghats. Western Ghats are mountains which we'll learn in the Indian geography. These Western Ghats, they will not let the rain to happen in this part of the area. Okay? See here, there will be winds which can be present on either. Let's imagine these are your Western Ghats, these are your Western Ghats, and these are your Eastern Ghats, right? So this Western Ghats and Eastern Ghats, they will not let the wind to enter into the central region. Why? Because if this is your mountain, you will come across, the wind will start to rise and then it will rain on this side, and this side is called as windward side, and the other side is called as rain shadow side, rain shadow region. Now this is the regions where you will not have any rain, right? So look into the central part of the area between these two mountains. You will come across a region called Rayalaseema. This is a rain shadow region where there won't be any rainfall, right? Because the moisture is dead by the time other side of the mountain it goes, right? This is one region. Likewise, you will also have another region in India, the Ladakh. Ladakh is a region which will not receive any rainfall because it is on the rain shadow side. Spiti Valley is also on the rain shadow side, right? Likewise, you'll have different set of regions, right? Okay. So this dry region is called as rain shadow region of Ladakh. This is because of the orographic rainfall. Your orographic rainfall is also high in the Himalayas and in the northeast region of Cherrapunji. Cyclonic rainfall usually happens because of a cyclone that we have studied in the last class in a detailed manner, that is called as cyclonic rainfall. When it comes to convectional rainfall, every day this near to the equator, this convectional rainfall happens at 4 p.m. or 5 p.m. Usually near to the equatorial region, you see there is so much of moisture that is available. Look here, at the equatorial region you have so much of moisture that is available and good amount of heat. All the air rises. Now the air, while they rise like this. It is like this. Look here, suppose this is the ground. First the air in contact with the ground will get heated and there will be moisture that will be rising. Let's say this is the air that is rise. Now this air will shift upper and a new packet of air will get heated again. It is like the new packet of air will get heated and this will shift little higher. Again a new packet of air will be getting heated here. This will be the new packet of air. The green color packet of air got shifted one step higher and the white color packet of air will get shifted little more higher. Likewise, the entire region gets heated as well as the moisture is rising and rising. Over a period, they will form a big cloud. This is your cumulonimbus clouds. Like that, thousands of clouds will be there. All of these clouds, they will release their moisture in the evening. This rainfall is called as convectional rainfall, which is every day seen at equator, right? In sometimes during the monsoon time period, before the onset of monsoon, when you are having winter, when you are having summers in the month of May, these rainfalls can also be seen in India, in the Kerala, and it helps in mangoes flowering. This is called as mango showers. Same way in Karnataka also you will see them before the monsoon. It will help in blossoming the coffee plantation. That is why they are called as blossom showers. In West Bengal also these are called pre-monsoon showers because of the convection. They are called as Kal Baisakhi. Okay? These are the names which are given to the convectional rainfalls in India. They are present just before the onset of the monsoons, right? They are present just before the onset of the monsoons, right? Mango showers, blossom showers, and the other. Clear? Okay. This is what is all about the chapter number 10. Very easy. But now to come to chapter number 11, it talks about the climate and the climatic types, right? See, this is one chapter which many of the students do not understand because they don't know where are the easterlies, where are the westerlies. So I'll try to give you a brief overview about this, but I definitely want you to read these chapters as well. It's not that without reading the chapters you won't be in a position to understand them in a detailed manner, right? So this particular chapter, what you are supposed to do is first you need to understand how the climate of the world is divided into. See, the climates of this world are divided by many people. Okay, the climates of the world are divided by many people, but Koeppen is the person. Here we are going to learn about a person by the name Koeppen. Koeppen, he is the first person, this person, who tried something practically. Okay, by taking some numbers like temperatures of rainfall and temperatures values he has taken and tried to give us how the climates of the world can be divided into, and he has given some names to those climates. This is what is all about the chapter, that is climate and themes of the climate, that is world climate and climate change, right? World climate and climate change, right? So the world climate is divided by the Koeppen on the basis of empirical formula. What is empirical? Empirical means you are using data. He used the data of temperature. He also used the data of precipitation, that is rainfall, snowfall, sleet, like that. And he has divided the entire world into few different types of climates, right? So what has he done is, look at this. This is the world, right? On this world, you also know that the entire world can be divided on the grid lines, that is your equator. You know about easterlies, westerlies. Now look here, please try to draw the easterlies and westerlies here. You already know if this is your equator, near to the equator and somewhere in the Tropic of Cancer and Capricorn, these are your easterlies. Okay? And this is your easterlies, right? Suppose these winds are coming from east to west. This is your east, this is your west. If winds are coming from east to west, the moisture will be carried on the eastern side. From the moisture that is carried here will be taken forward and it will rain in this part of the region. It is always the moisture is carried. If the wind is coming from the eastern side, the wind will carry the moisture and this moisture will be given to the areas on the western side, right? So broadly, winds are nothing but something which is having moisture and they'll carry the moisture like this. You know that there are southeasterlies and southwesterlies, southeasterlies and northeasterlies, right? So southeasterlies and trade winds, southwesterlies are monsoons. Look here, let's divide this entire region into three parts. It is like, this is India and these are the three parts, right? He said this part of the region he named a climate. He has given a name to this part of the region. He has also given a name to this part of the region. He said this part of the region receives less rainfall. Let's see if this is the northern region and this is the southern region. He says that I'll divide the world like this. And this is the belt where the winds come in this direction, that is east to west. This is east and the winds are southeasterlies. These are northeasterlies. The winds will not get moisture to this part of the region. He called this as desert. And on the basis of temperature, on the basis of precipitation, he has taken data. Like that, he has divided the entire world. Let's say he has divided the world like this into a grid. I hope you are able to understand this. This is the world. Now let's say this is Tropic of Cancer, temperate regions, and let's try to divide the world like this, right? And he has given names to these regions based on two aspects, that is temperature and precipitation, right? Precipitation means it could be rain, right? It can be snow, it can be anything, sleet, whatever it is. टेम्परेचर और प्रेसिपिटेशन. टेम्परेचर के ऊपर 4 रीजन्स को डिवाइड किया और बाकी रीजन्स को प्रेसिपिटेशन के ऊपर डिवाइड किया. लेट्स ट्राई टू अंडरस्टैंड व्हाट आर द पैरामीटर्स ही हैज टेकन. He has taken the parameters of number 1. He told that I will consider any area. He said I'll consider any area which is having a temperature of 18 degrees Celsius or more. Let me use the slide so that you can see it easily. He said, I'll take tropical regions or a type of climate or any regions who are having a temperature of 18 degrees Celsius or higher in the coldest month of the year. The average temperature of the coldest month of the year, if it is greater than 18 degrees Celsius or higher, I'll call this as a type of climate and I'll call it as a tropical climate, right? So do you have the average temperature in your area to be in the coldest month is usually either December or January? In that year, do you have a temperature of average greater than 18 degrees Celsius or lesser than 18 degrees Celsius? You let me know in the, you can drop me a message and let me know the place. I'll tell you whether you have the average temperature of 18 degrees Celsius in the coldest month or so. Let me go to Punjab. Punjab in the coldest month is not having 18 degrees Celsius or more. I won't be calling it as tropical region. But go to Tamil Nadu or go to Telangana, Andhra Pradesh. Even in the December or January, the average temperature will be greater than 18 degrees Celsius. They are tropical climates. Likewise, you see, he said C is also taken on temperature. He said the temperature of the coldest month of the mid-latitude climates is higher than -3 but lower than 18 degrees Celsius. He says that I'll call this as a temperate region which is considered to be warm temperate. That is, temperature should be greater than -3 and lesser than 18 degrees. He'll call it as warm temperate region. Likewise, snow and cold frost, he said cold regions where the temperature in the coldest month is less than or -3 or below. It should be -3 or below. He'll call it as cold, snow, forest type, and he'll call it as D type of climate, right? Likewise, E type of climate is average temperature of all the months is below 10 degrees Celsius. H type of climate is cold due to elevation. Now I did not talk about B. See, B is the only type of climate which is taken into consideration based on rainfall. Did he talk about rainfall in the A type? No. C type? No. E type? No. H type? No. D type? No. The only climatic region which talks about precipitation is B type, right? Potential evaporation is greater than precipitation. That means the rate of evaporation is more than the rate of precipitation. That means if the rate of evaporation is more, then this particular region he'll call it as B type of climate. Now he further divided these type of climates. The divisions of this climate is within the A type. A type is greater than 18 degrees Celsius in the coldest month. If that is, let's say Tamil Nadu or the state of Telangana is having the coldest temperatures to be greater than 18 degrees Celsius. Now within that, he'll divide whether it could also be a tropical wet type of climate, it could also be a tropical monsoon type of climate, or it can be a tropical wet and dry climate. He has divided further them into AF. He said tropical wet means AF, tropical monsoon means AM, tropical wet and dry means AW, for which he said he has given some characteristics. Those characteristics are, in the A type of climate, there should not be no dry season. That means there should not be any dry season and the temperature should be greater than 18 degrees Celsius. He says this type of climate, I'll call it as AF. Right? This type of climate, he'll call it as AF. No dry season. Temperature 18 degrees Celsius se hona chahiye, and there should not be dry season means every month there should be at least a decent amount of rainfall. Where do you find? Near to the equatorial regions. Every day you will have rainfall, and also in every day there will be temperature greater than 18 degrees Celsius. Come to AM. AM means, he said, tropical monsoon type of climate, for which शॉर्ट ड्राई सीजन होना चाहिए, मतलब साल में एक आध सीजन ड्राई हो सकता है. दैट मीन्स, कैन आई से दैट केरला is a monsoon region? Northeastern part of India has 18 degrees Celsius or more all throughout the year in India, and they'll have only one season which is dry. rest of the season it will have rainfall, right? Likewise, tropical wet and dry type of climate, AW type of climate, winter dry. In this manner, he went into B type and he divided the B types into further different types. B type can be further divided into subtropical steppe, which he says that as BSH. These are very factual in nature, and see, Koeppen has divided these type of climatic forms way back in the year 1920-30. But is he 100% correct? The answer is no. He has only taken temperature and precipitation into account. Did he take topography into account? Did he take the population into account? No. There are many other factors Koeppen did not take into account. Animals he did not take into account. Animals can change the climate of that region. He has only taken the empirical data. That means the data which is based on the values, right? Data of precipitation and data of temperature. So most of the times it is factual in nature, but broadly it is not 100% true. For easing in the sense to make the climates little easy to understand and to keep the data of these climates, we have classified this. In the modern era, not all countries will follow this. Few countries might take it as a appreciation, but nevertheless, after him, there are many other people who have given the classifications for the world. We give credit to him because he is the first person who have tried to understand the climate based on the empirical data, that is values, temperature and climate and vegetation. So he has taken temperature and precipitation and some parts of the vegetation into account, right? So B type, he'll say that a region is called as a subtropical desert in the low latitude area if it is having dry region, and he'll call it as subtropical steppe. Steppe मतलब छोटे छोटे grasses होते हैं, ठीक है, छोटे छोटे grasses. Desert means there is no rainfall. This steppe means low latitude semi-arid area, मतलब पूरा dry नहीं है, थोड़ा dry है, there is little dry. Likewise, he'll go to mid latitudes. Mid latitudes मतलब थोड़ा ठंडा इलाका. ये दोनों है ना, like that he called it as BSK. He called mid latitude deserts as BWK. Mid latitude and arid and dry climate he called it as BWK. So these are some classifications that he has given. Now come to C type. C types are those areas where the temperature is less than -3, greater than -3 and up to 18 degrees Celsius, right? Now he says that CFA, CS, CFB, for which humid subtropical is said. Humid subtropical means it is no dry season or warm summer, right? He also gave CS. CS means dry hot summer. Like that, he also gave other types of climate, that is CFB, no dry season. काफी factual है, but to make it easy for you, what I have done is I'll divide them and give the names to these climates based on the map. Look here. What I have done is, to make it easy for you, look, the entire earth is divided into slots like this. Imagine this is your earth. This earth can be divided like this, right? Right? This is your equatorial region. This could be a subtropical region. मतलब यहाँ पे वेस्टर्लीस होता है, तो वेस्टर्लीस यहाँ से बारिश लेके आ सकता है, ईस्टर्लीस यहाँ पे बारिश लेके आ सकता है. So like that, the entire climates, we need not go into that technicalities, but I'll try to give you a better understanding, and this is one thing that you can remember, right? All the climates can be divided into these types, right? So Koeppen का CFA, CFB बहुत ज़्यादा मुश्किल है यार, जितना हो सकता है. In the advanced classes, we will be doing it in a detailed manner, but now let's try to understand the Koeppen's classification and put it onto the map. There are different types of names that are given to these climates. For example, look here. Let's go to the equatorial region. Equatorial region पे कोई climate होता है क्या? नहीं. Every day there is rainfall, every day there is sunlight. So he calls this climate, that is 0 degrees to 10 degrees north and south, hot equatorial climate, where the temperature is equatorial rainforest. Can I call this the temperatures to be having 18 degrees Celsius plus even in the coldest month? Do you have any dry season? No. If you are not having a dry season, can I call this climate as AF type of climate? 0 to 10 degrees north and south. Now come to 10 to 30 degrees north and 30 degrees south. What kind of winds do you have? You have easterlies. Now come to 45. What kind of winds do you have? You have westerlies. And even in the 45 to 65, what kind of winds do you have? You have westerlies, right? See, why am I focusing more on easterlies and westerlies? Though these are not there in the NCERT, I'm giving you little more extra so that you can understand, make your topics little easier, because this is one of the toughest chapters. So in the polar region, what kind of winds do you have? Your easterlies, right? See here, he has divided the entire temperate region into, this is called as 30 to 45. He called it as warm temperate region, and 45 to 60 he called it as cold temperate region. He has divided the temperature region into two, warm temperate and cold temperate. So see here, first go to the easterlies area. The easternmost area is the region where you receive good rainfall. He said a region that is having 18 degrees Celsius plus temperature in all throughout the year, plus the rainfall you get to see here is, the rainfall that you get to see here is seasonal, and only one season that will be dry, for which he gave it as monsoonal type of forest will be there, monsoonal climate. Can I call this particular climate as AM, monsoon type of climate? Can I call this as AM? Now come to this region, as the winds come to the eastern side little more, they'll lose the moisture, and here the trees will not be forest, they will be grasslands. They are steppes. Steppes means these are, the grasslands are having little 2 meters of height in the tropical regions and 1 meter of height in the temperate regions. So this is steppe, this is called as Sudan type. Sudan in the sense जहाँ पर tropical grasslands मिलता है. You go to Africa, you will find Sudan. Now where is this Sudan? Let me show it to you. This Sudan is somewhere here. Where do you find monsoon type of climate? This is your monsoon type of climate. ठीक है? ये आपका AM है, monsoon type of climate. Now what is this type of climate? Which is, he said that this is the region where Sudanese type of climate जहाँ पे grasslands होता है. ये region जो है ना, इस region को इन्होंने कहा Sudan, जहाँ पर grasslands होता है. And this region he called it as desert. Right? So he has divided the world into temperates and climates of this sort. Right? This is your Sudan type, and this is your hot desert, that is your vegetation is very dry, rainfall will be dry. Now can I say that as I am moving from east to west in the tropical regions, the rainfall here is more, the rainfall here it is reduced, here rainfall is not there, right? In the tropical regions, if I am moving from east to west, I am not having good rain, right? Okay. Come to the second type, that is your westerlies belt. Is westerlies belt, देखो, this is called as Mediterranean type. Now where do you find this Mediterranean type of climate? On the western margins of the continents between 30 degrees to 45 degrees north. This is Mediterranean. Now come to the central part of the area. मतलब यहाँ पे rainfall ज़्यादा होता है, यहाँ आते आते rainfall थोड़ा कम हुआ, और यहाँ पर थोड़ा rainfall, mixed rainfall होता है. So this is China region. This is steppes, temperate grasslands. Russia region में जो steppes grasslands है, and Europe region में जो steppes grasslands है, that is where is your steppes. The height of the grasslands is smaller here. The height of the grasslands are bigger here. Come to China type. These are warm and wet. मतलब एक season warm होगा, एक दूसरा season wet होगा. यहाँ पे rainfall is seasonal, right? But it is comparatively colder as compared to this region, that is tropical region. Now come to little more higher regions, that is 45 to 60. He says here also you have western margins. यहाँ पे भी बारिश ठीक ठाक होता है, और continental type, go to Siberia. The temperatures will be extremely cold in the latitudes of 60 to 45. So you'll have extremely low temperatures here, and vegetation will not be of grasslands, but you'll have the coniferous trees, the thick tall coniferous trees which are there. Christmas trees जो होता है ना, वो वाला trees होता है यहाँ पर, right? Now come to the eastern side. This eastern margins is also called as Laurentian type, from 45 to 65, right? And you go to the polar region. This is your polar Arctic. In this, lichens and mosses will be found. Small species will be found. So in a total scale, if you look into all the climates which are there, which are too factual into, to make it simple, I've put it like that. And then let me show it to you on the global scale, how the desert plantations are there. This is how the plantations of the deserts will be there. They are cactus. These are your cactus plantations. Likewise, you go to the roots of these plantations. The roots of these plantations are too deep, thick roots hota hai. They are, the water will be stored in them itself, right? Likewise, let me show you few other aspects. That is, where do you find these type of climates? AF type of climate कहाँ पे मिलता है? AF मतलब it is the region where temperature is greater than 18 degrees Celsius. A मतलब ही 18 डिग्री सेल्सियस से ज्यादा. So ये जो temperature है, you'll get in the equatorial region, right? Equatorial rainforest है. Now let me show you the next type, tropical wet and dry type. That is AW. Tropical, wet and dry. This climate is seen. Where do you find? Look here. Tropical, wet and dry. Tropical, wet and dry. So this tropical, wet and dry, which is AW, is seen as in India also you'll find, in Africa, and in this part of the regions where you'll have monsoon. Now look into subtropical, humid subtropical region. This is CFA. CFA is the region of this map. Likewise, Mediterranean. I told you Mediterranean climate is found in the western margins, right? Look at this Mediterranean. In either sides, in both the hemispheres, this is your Mediterranean. Where do you find this Mediterranean? In the westerly belt. This is, if this is the world, he said like this, he said this is warm temperate. This is the region where you'll find Mediterranean. Can I show it to you again? Where do you find this Mediterranean? यहाँ पर है ना? In the western margins. So let me show you the map of the world within the 30 to 45 latitudes. On the western margins, you will find that. So this is your Mediterranean. ये है आपका Mediterranean type of climate. Between 30 to 45 degrees north and south latitudes. This is 30, this is 45. वेस्टर्लीज होता है यहाँ पर भी वेस्टर्लीज है, इसी लैटिट्यूड्स में वेस्टर्लीज है. सो दिस इज वेयर योर मेडिटेरेनियंस विल बी देयर, राइट. कम टू द नेक्स्ट टाइप, दैट इज CFB. CFB is marine west coast climate. You go to little more north, मेडिटेरेनियन के ऊपर जाओ. This Mediterranean, just above the Mediterranean is this marine west coast climate. Go to the colder temperate region, 45 to 60 के बीच में. So this is called as marine west type climate, right? On the western margins. Come to humid continental. ये Siberian type of climate जो है ना, यही है humid continental climate. Come to subarctic climate. Near to the polar region you will find this type of climate. No true summer in the northern regions. Like that, these are all your permafrost region. Permafrost regions are in the Arctic region. These are your Arctic regions जहाँ पर completely it is tundra type of climate, जहाँ पर vegetation कुछ नहीं होता. It is fully permafrost region will be there, right? This is your permafrost region. And overall, the climatic classification of, if you look into the climatic classification of Koeppen, he said you only need to understand what are the major dimensions he has taken. He has taken a type of climate and he has subdivided many types of climates into this. And since last 12 years there was only one question that is asked from this particular topic, but still I have to teach you so that maybe somewhere or the other you can narrow it down. देखो कुछ ऐसे चैप्टर्स होता है रटना बहुत मुश्किल है, मगअप करना बहुत मुश्किल है, बट लॉजिक से मार सकते हो आप. लॉजिक ऐसा है ना, देखो ये ए है, मतलब ग्रेटर देन 18 डिग्री सेल्सियस होना चाहिए आपका कोल्डेस्ट मंथ. बी है, इट इज प्रेसिपिटेशन के ऊपर है जहां पे एवोपरेशन इज ग्रेटर देन प्रेसिपिटेशन. सी है, इट इज वार्म टेम्परेट, मतलब आई टोल्ड यू इफ दिस इज योर अर्थ, फ्रॉम warm temperate means 30 to 45. He called this part of the area as warm temperate, 30 to 45, and cold temperate means it is 45 to 60. Like that, these are your dry climates based on precipitation. Warm temperate means जहाँ पे -3 डिग्री सेल्सियस से ज्यादा होना चाहिए, बट 18 डिग्री सेल्सियस से कम होना चाहिए. दिस टेम्परेचर, it should be greater than or equal to -3, but it should be less than 18 degrees Celsius. Whereas cold snow, the average temperature of the coldest month is -3 or below. That means the cold snow forest type of climates -3 degrees Celsius se it should be less, right? It should be less than -3, right? E is cold type of climates, right? E is cold type of climates. Average temperature for all the months is below less than 10 degrees Celsius, right? Average temperatures of all the months is less. Now he said cold type of climates. Last is highland. Highland due to elevation, मतलब ये जो temperatures है, these highland temperatures are nothing but your mountains, which are nothing but the Himalayas, Himalayan type of temperature, right? So this is how the Koeppen's classification is done, and this Koeppen's classification is the one which you will get to have a beautiful idea on how to divide the climate into further types. Now this is what is written in your this entire chapter, right? So very basic hai, it is easy just if you know the divisions, how they are divided, right? There are connotations that are given to each of these connotations, such as, look here, the connotations are none other than, number 1, here we have dealt with A, B, C, D, E, but in this you will also find some other connotations, that is the shorter connotations. What do you mean by F? What do you mean by other types? Such as, let me show it to you. In the same chapter, they'll write it here. M का मतलब क्या होता है? Look here. Here M is equal to monsoon type of climate. Chota W is equal to winter dry, and small s means summer dry. And then he has used A, B, C, D. A, B, C, D. A, B, C, D, the degree of severity of the temperature means B, A मतलब ज्यादा टेम्परेचर है, D मतलब कम टेम्परेचर है, ठीक है. एंड देखो कॉम्बिनेशंस क्या है, यू हैव A, B, C, D, E, H. These are the major. A means 18 degrees Celsius or greater than or equal to 18 degrees Celsius in the coldest month. B means where the precipitation should be less than evaporation, the rate of evaporation should be more than the precipitation. That means where you can find this B type of climate. Can I say that this B type of climate can only be found in deserts? This is found in deserts or cold deserts or warm deserts. C का मतलब क्या है? C means temperatures which are having greater than or equal to -3 degrees Celsius and less than or equal to 18 degrees Celsius. This is your C, right? D type of climate जहां पे टेम्परेचर -3 डिग्री सेल्सियस से ज्यादा होना चाहिए. अगर ऐसा कैलकुलेशंस किया, और देखो S मतलब समर ड्राई, A S, कैन आई से दैट, कैन आई क्रिएट A S टाइप ऑफ क्लाइमेट जहां पे 18 डिग्री सेल्सियस से ज्यादा हो, बट समर की महीने में, in the months of summer, the temperature, it should not have any rainfall. Can I have AW. AW means during the times of winter it should be dry. A region which is having greater than 18 degrees Celsius temperature, but it should also be dry in the winter, right? Can I have AM, where this AM means 18 degrees Celsius से ज़्यादा होना चाहिए और monsoon. Now in India, which place do you live? Do you live in a place where you have monsoons and having a temperature of greater than 18 degrees Celsius? Or do you live in an area where the winter is dry in your area? There is no rain in the winter, but all throughout the year you are having 18 degrees Celsius temperature or more. Or do you live in an area in India where AS, that means greater than 18 degrees Celsius is there, but during the summers it is dry. Next, come to B type. If suppose they say that BS type of climate is there, let's say BS type of climate, right? So BS type of climate matlab jahan par B in the sense the rate of precipitation, rainfall should be less and the rate of evaporation should be more. Can I say BS means the rate of precipitation is more, rate of precipitation is less and the rate of evaporation is more, and it is dry in summer? And BW type of climate can also be there, BM type of climate can also be there. But Koeppen, what he has done is he has also taken A, B, C, D छोटे छोटे letters. This A मतलब B, S, A मतलब ज़्यादा ही dry है, A मतलब ज़्यादा dry, B मतलब कम dry, D मतलब little less dry. It is saying that the degree of temperature, ठीक है, the smallest letter A, B, C, D, it is ज़्यादा dry and it is extremely hot, it is little hot, ठीक है. A means extremely hot, D means little hot, right? In this manner, you are going to divide the entire world into different types. So this is what is Koeppen. It's just that the names of these climates you need to learn. For that, all you need to do is just remember the values. A greater than 18, B precipitation is less and evaporation is more, C less than greater than 3 degrees Celsius, less than 18, D type of climate less than 3 degrees Celsius, E type of climate जहाँ पे 10 degrees Celsius से कम होना चाहिए all throughout there, and H type is highland type of climate. And then come to the little more classifications, that is F क्या, B, C, D क्या होता है, S क्या होता है, W क्या होता है, M क्या होता है, right? If you are clear with that, it will be easy. It's just the connotations that you need to know. In the further classes, you will have more clarity. So don't worry. In the advanced classes, what we are going to do is we are going to learn about each and every type of climate in a detailed manner. There will be one question that can be asked from here for the prelims examination, and for mains, there are chances that climate questions can be asked. Now come to the last topic, that is climate change. Come to the last topic, that is climate change here. See, how does this climate change? Gases, greenhouse gases which are rising, why is this alarming rate? In simple terms, I already told you in the previous classes that greenhouse gases has a unique phenomena. What is this unique phenomena? If suppose this is your earth and if these are your greenhouse gases, what carbon dioxide is also a greenhouse gas, right? This carbon dioxide, what does it do? It is transparent to the incoming solar radiations, which we have already learned. It is transparent to the incoming solar radiations. But the same earth which is now heated, if the earth got heated and it is sending out the rays, they will trap this particular heat. Because of that, all the heat which is sent by this earth, this heat is getting trapped and your atmosphere is getting heated, and because of that, glaciers are melting, right? Polar bears have to move from that glacial place to a different place. Likewise, species had to migrate from one place to another place, and this beautiful earth is rising its temperature from average temperature of 15 degrees Celsius to, by the year 2100, 17 degrees Celsius plus average temperature होगा. उससे क्या होता है? जितने भी oceans है, look here, all the oceans, I've already told you, our earth is full of oceans, and this earth, it is so You think this is a bowl of water. If you're starting to heat this bowl of water, what happens to the bowl of water? The water will start to spill out. Likewise, if you're going to heat this earth, the water will enter into the coastal areas, right? Sea level changes are going to be there, and our sea can come onto our coast. People, 50% of the population is living on the coastal area, and this 50% of the population is the one which is going to move from their particular places. And think of the small island countries, that is the Maldives, the Tuvalu Islands in the Pacific Ocean. Like that, there are many small islands. Where are these people going to go? Okay? There will be future. They'll try to rush to different places jahan pe continents are bigger, and world's most biggest cities are on the coastal areas. What about people living in Mumbai, Chennai? They'll be moving inside. But what about the countries which are completely islands? They will be the climate refugees. A new refugees you will come across, that is your climate refugee, right? So in totality, this is what is your climate change concept. It is a very deep concept. Greenhouse gases are the ones which are increasing the climate. And what are these greenhouse gases? The fundamental greenhouse gases are carbon dioxide, CO2, CH4, that is methane. Water vapor is also a greenhouse gas. Other greenhouse gases, they are heating the earth by when you are releasing the hot industrialized gases, right? Hot industrial gases, if you're releasing, this is what is going to happen. So this is what is about all of this chapter. In the next theme, I will be coming up in a detailed manner. I would ask you to watch this particular theme at the later stages of your NCERT. Even if you do not understand, I want you to read them again. Few students might find it difficulty, so don't worry here. Things will be fine once you have done with the other chapters, right? Thank you, and I'll be seeing you in the next theme.